So this is 5.4, statements of proportionality. So this first slide here definitely takes some time to pause and write this down if you need to, but what we have here is a similarity statement along with diagrams of two similar quadrilaterals. So we have quadrilateral corn that is similar to quadrilateral MAIZ, or maize, I guess. Corn is maize. And then along with that, we have our corresponding angles. And if you remember from the first lesson, 5.1, if you have similar figures, their angles are going to be congruent. So angle C is congruent to angle M, and angle O is congruent to angle A, and so on. And they're marked that way in the diagram as well. Now, a statement of proportionality, and we've touched on this just a little bit, but it tells us which parts of each quadrilateral are proportionate. Okay, so what that means is if we have on top here, you can see that we have side CO, side OR, side RN, and side NC. Those are all parts of, I should have made those all capital, CORN. Okay, so all of our CORN sides are on top. And then if you look at the bottom, those are all of our MAI. Z. So you want to make sure that when you're writing statements of proportionality, you keep those things consistent. So all of the corns are on top and all of the mazes are on the bottom in this case. And there's a couple different ways that you can go about setting those up. You can either look at the original similarity statement. So you have CO and MA. They go together because they're the first two letters. Then you have OR and AI. Those go together because they're the second. And then you have your third and fourth letters, those go together. And then finally, you have your last and first, and those go together. So that's one way to do it. The other way to do it is to use your diagram, and it's especially easy in this case when your diagrams are oriented the same way, like they look the same way. They're not flipped upside down or reflected or anything like that. So you could do it that way as well. So you could do, let me go back to the right color here. We could do CO goes with MA, and that's how we had it set up. And then I'm not going to do all of these. We could keep going. We could do OR, so like the bottom goes with the bottom. Okay, so we don't know that those parts are congruent. In fact, looking at the diagrams, it doesn't look like they're congruent, but they're going to be proportionate. Okay, which means I'm just going to pick an easy example again. So I'm just going to label the sides like 2, 3, 4, and 5. And say the second diagram, the MAIZ, say it's twice as big. So you're going to have 4 and 6 and 8 and 10, and I'm totally just making up those numbers. But if you were to put those numbers back into your proportionality statement, so instead of CO, I'm going to put in 2, and then instead of MA, I'm going to put in 4. Okay, that's equal to, that ratio is equal to OR over AI. So if I find OR, that was 3. And if I find AI, that's 6. Okay, so right away, just ask yourself, is 2/4 the same as 1/6? Well, yeah, they're both equal to a half. 2 divided by 4 is a half, 3 divided by 6 is a half. So far, so good. And if we keep going and we did RN and IZ, we would have 4 over 8. And yep, that's equal to a half. And then our last one, NC is 5, ZM is 10, and that's also 1/2. Okay, so proportionality statement or statement of proportionality looks like that. You can either use letters or numbers, or just kind of depending on the situation, you'll go between the two. All right, so we're just going to do one example here. Again, pause, get the diagram drawn in your notes. But what we have here is another set of quadrilaterals. We have dent is congruent to bath. Dent is congruent to bath. Okay, and we're going to go through just a couple things here. So first thing we're going to do is we're going to write one of those statements of proportionalities. Okay, so what I would suggest doing here is looking at, since they're not oriented the same way, look at the similarity statement rather than the diagrams. So DE goes with BA. So DA is proportionate, sorry, DE is proportionate to BA. Okay, and then just keep going. So those were our first two letters. Now do your second and third, and second and third. So EN and AT. And keep going. So the next one would be NT and TH. And then we want to go with last letter, first letter. So TD and HB. All right, so that's a statement of proportionality. If you have four sides, you're going to have four ratios. If you have a triangle, then you're only going to have three, okay, and so on. All right, and then part B. So I gave you here two ratios, one that's complete, so 8/6, or 8:6, and the other one that's not complete. So our job here is to figure out what goes with that 5, what goes underneath the 5. So to do this one, I think we're probably going to want to use our diagram, maybe the similarity statement as well, but for sure the diagram. So I'm going to find 8 and 6. So 8 is here, and I'm just going to make a little mental note there. So 8 is that side TD. Okay, and then 6, if we look at our diagram, we need to look at our second figure. It is our HB. Okay, so we have our dent diagram on the top, and we have our bath diagram on the bottom. So we need to keep that in mind. Next thing we're going to do is we're going to go find the 5. Okay, and the 5 is right here. It's between D and E. So I'm going to make a little note of that. D, E. Okay, now the question is first, which side goes with DE? Well, we have that proportionality or statement of proportionality right in front of us. So the first one we used was right here. Okay, that was this guy. Okay, now we need the one that has DE on top. And it'd be that one right there. Okay, so what goes under DE? Well, BA goes under DE. So I'm going to go back. I'm going to find BA. BA is right here, and it's an X. We don't know what it is, but it's an X. We don't know the number, but we know that it's X, and that's going to be our BA. So when you're doing these problems, I would always start with that statement of proportionality. That makes filling in the rest of the problems a little bit easier. Okay, and then the last thing is to solve for X. Well, the good news is we've already set up a ratio. We did that in part B, so all we need to do is use our proportion, what we know about them, our skills, and solve it. So we're going to cross multiply. So 8 times x is 8x. That's equal to 5 times 6, which is 30. Divide by 8, divide by 8, and x is going to be approximately, or maybe perfectly, we'll see, 30 divided by 8. Grab a calculator. 30 divided by 8 is 3.75. So I guess we could change that to an equal sign. All right, and then last thing, I know this video is getting a little on the long side, but I would always check my work there. So I would always substitute that back in and just make sure that those proportions or those ratios are actually congruent or equal. So I would do 8 divided by 6, test that in a calculator. So 8 divided by 6 is that. And then our other one was 5 divided by 3.75. 5 divided by 3.75. And you can see that we get the exact same answers there, 1.33333 and 1.33333. And you can actually, if you want, you can turn these into fractions, both equal to 4/3 once they're reduced. All right, that's it. So go ahead and get going with the 5.4 practice.